Okay, so welcome guys to the second part of this series, the Build a Game with Rust series using Bevy Engine. And today is going to be the second part, which is the part two. To proceed from where we stopped yesterday, which basically was just to start up with a simple option, right? And understanding what Bevy is generally and how easy it is to create some impressive games, like using the ECS paradigm that it provides for you, and other things like that. So basically, the idea is just to create a game and to learn Rust using that same approach. So that's why we are building this. So this is a, I don't know how many days series is going to be, but it's going to be just fun while we go along and also to learn. So all right, so to get started with this or to proceed, since we already just to continue from where we stopped yesterday. So let me share my screen and let's get started from there. And okay, so if you remember what we did yesterday, that was like the introduction basically was to kind of get started, and then we did this simple UI that you see on the screen that shows you how Bevy works generally and how you can implement something like this. And then we created a viewport. This is the viewport. This black area here is the viewport. So everything we did here is just one of the examples. We just picked an example from Bevy generally and tried to rework some of the things. So this was one we did yesterday, to the viewport word, whereby we created a viewport right to the world. So there's a word system. There's a word, there's a system, there's a component, there's entity, there's renderer, and there's a scheduler. So everything we talked about yesterday. So today is basically still explaining more things, right? Trying to build something. But this time around, I'm actually going to build a game today that makes a lot more sense. So we're going to still be using one of the examples, but to create something that makes a lot more sense. So before we pick any of the ones we are going to do, we're going to check it out because Bevy has a way for you to display this on the browser using the WASM. So you can actually render any of this game on the browser. So imagine if you build something so interesting and then you can see allow it to be played online, whether multiplayer or whatever. So and still you're still in about Rust because everything we did yesterday, if you guys could remember, we talked about the plugins, the systems, creating components, what components are, entities, how to implement, what structs are basically, that component are structs, the systems are functions, and then you bring them together and you just create something that makes sense. So that was the idea. That's basically what we did yesterday. And so we were able to create something that makes a lot of sense from there. And so today we are going to look at more options, right? So let's look at some of the other options that we have. So this is a Bloom, illustrates Bloom post-processing in 2D. So I'm not going to go deep into the whole gaming stuff because the idea of this is to be able to build a game using Rust, right? Whereby it kind of like helps you to learn. So while you guys understand it and as we proceed in this daily series, it's going to be we create much more um a much more playable game. But then you should have an idea of okay how Rust works. Like I said, it's beginner friendly, right? It's not just created for anything. Basically, it's beginner friendly in the sense that whether you know Rust or not, whether you have an idea of what Rust is or not, you can still pick up Bevy and game development and start with it, and it makes a lot of sense. So in 2D, we understand 2D and 3D. 2D, for most of you that might not know the difference, 2D is just a flat plane surface whereby you have like a rectangle, a circle, they are 2D. But then when we talk about 3D, we are going deep into like the third dimension whereby we can perceive there's depth basically, and depth in terms of like you have the weight, the height, the width, and the breadth. And the breadth in the sense that you can now have another dimension. So if you talk about it, a triangle, a rectangle, for instance, a rectangle has a length and height, right? Or let's say width and height. So that width is the from one side to the other side, and then the height is how long the rectangle is. So that's a 2D plane, a 2D shape. A 2D shape can just rotate like that, but in a 3D shape, you can now see beside it, but in a 2D shape, you can't really see beside it, just the front and the back. So basically, that's the idea of 2D. So 2D is easy to create mostly, but not really easy to create. Let me scratch that. For most game devs, it's actually subjective to what whoever you ask. So basically, it's quite understandable to start with that. So to proceed with this, so now let's check another example today, just to kick off what we're trying to do here. So say we are using this example as an option. It's actually subjective towards. So let's pick this as an example. So let's talk about 2D bloom. Let's use 2D bloom as an example here. So if you look at this, let's open this in a new tab and see what it does. We just pick one that is interesting and then we walk around it and try to see if we can create other things. But remember when I said yesterday that we won't just be writing this on our own, because now we are in the age of AI, and AI is here to help everybody make your work easier. So I'm going to be teaching you how to also use AI to speed up your workflow and your work process. So you don't really need to write everything yourself in terms of like, oh, I want to write this logic, you need to think extra hard. No, you can use AI to leverage all of those and make it easy for you to proceed. So looking at this code base, if you've gone through what we did yesterday, or you were part of those that were on the series yesterday, you realize that this is something we can read now. We understand that we are importing Bevy and all the processing we need. In this case, we are importing the core pipeline. And the core pipeline contains the tone mapping, the deband data, and the tone mapping also, which you import from the tone mapping, which is this guy. And then you have the post-process function, which was also imported, and all of those things. So basically, these are just the general imports. Then we have the main function that defines the plugins and the systems. Remember when we talked about the plugins, we imported the default plugins, the systems, and then we had the system. So we added two types of systems here, the startup system and the update. And we kept updating that to make it work for what we want. Another thing we did here was, now that we have the system, we have the startup, right? And we know that the startup here basically is the so when we define our system here as a function and we add a startup scheduler to it, we are simply saying that we are scheduling this to run on startup. So this setup should only run once when the application starts. So that's what is going to happen on setup. So on setup here, if you look at this now, we are creating a 2D camera plane, we are creating a camera instance, we are creating a tone mapping instance, we are creating the bloom and the band. So basically what you want to create determine what you import to use to supplement the logic. That's basically what is happening here. So this is just an illustration bloom post-processing in 2D. Right. So just so let's proceed. So that is basically the first thing. You create this setup, you use the startup scheduler to define what we want to run on startup. So on startup of this application, I'm going to do something very, very easy here. So I'm going to start with creating, from where we stopped yesterday, we created this, right, which was the main, and then the viewport to world was another thing we created, which displays this for us. And we can see this, we can see all of this. So I'm going to close this, and then I'm going to create a new one, a new file here. I'm going to call it bloom to 2D. Is the name bloom 2D? Okay, bloom 2D is just what I'm going to call it. Bloom 2D attached to module, and then I'm not going to add that to Git yet. So the bloom 2D basically is this. So I'm going to be copying just some part of this that we need. The reason is because I want to show you guys how we are going to dissect it before we can start to now add other things to it. So let's start with just the basic imports and then all of this. So we know fully well that we don't have setup, because setup is defined to run on startup, and then we don't have the update bloom settings, which you update once per frame. We talked about all of this yesterday. So if you don't kind of understand, you can still continue with this. I'm going to make reference as much as possible to the previous video, but then if you have time, for sake of the depth of understanding, you can also pick up the first part. It's also on the same channel, and then there's going to be another series tomorrow. So if you're interested in that, it's best to just subscribe now and turn on your notifications, so that before the video starts, I'm going to create like a live event. I'm going to schedule it for like hours before we start, so you can get updated and then you can prepare to join and see how we are going to continue with the other series. So because we plan to build a lot of things in this series, and we are going to keep going more complex per day. So that's the idea. So today is going to be a bit more work than yesterday, but it's going to be fun because it's not going to be more of talk. We're going to be trying this, explaining to ourselves, seeing if we can tweak it, see the tweaks real time, and then we move from there, right? So that makes sense. So today is going to be this. So I'm going to copy the setup, but then I don't want to use the setup just like that, right? I'm going to copy it, but then I'm going to remove some things that we don't want, basically. So you can see what is happening as we're adding it to it. So you can create a setup function or just paste the setup function here. And the setup function here is basically taking command, meshes, materials. But I'm going to do some things. The first thing you're seeing here is spawning what we need. So what are the things we are spawning basically? Now, if you remember the first one, for those that were here yesterday or have gone through the video, remember when we created a spawn of great people or of add people yesterday, what we did was we added a spawn of struct or component as a tuple. The same thing is what is basically going on here. You can see that this is a struct because basically it is a struct. So this is a struct, this is a struct, this is another struct, and this is another struct. So you can see we're adding them in tuple. So you can see that we are building from the minimal version, which is this, to a more complex version. So what does this do? We're simply saying we create a camera 2D. A camera 2D, like I explained yesterday, okay, basically I didn't like go into it, but let me show you what it means. Now, a camera 2D is a 2D camera component. Remember, we say components are just structs that enables the 2D render graph for a camera. So if you want to check what the camera is, in this case, a camera is also a struct in Bevy. Is a defining component for camera entities, storing information about how and what to render through this camera. Now, this camera component is added to an entity to define the properties of the viewport from which rendering occurs. It defines the position of the view to render, the projection method to transform the 3D object into a 2D image, as well as the render target in which the image is produced. Now, a camera needs a render graph to render anything. So there's a camera 2D, there's a camera 3D, but everything is still a subset of what the camera struct, which is why we are creating a camera here as a struct, but defining the properties or the fields of that camera struct, which the first one is what? Declare the color. We don't really need this because if you look at the one we did yesterday, we didn't create that in the camera in initialization, right? We just defined, where was that? I think it's startup. Let's set up here. Yeah, this. You can see what we defined here. We didn't really define the clear color. We only defined the viewport in this case, and we defined the default. So the default is just all the other defaults of the struct itself. So in this case, we are concerned about the viewport. So we define the viewport. Here we are concerned about the color. So we are defining the color for the camera. Don't know if that makes sense. So that's basically what it is. So in this case, we are defining all of the things that will be spawned on startup. So all of these things will be available on startup, and then we can make use of it when we update the frame of the application, probably on first frame, second frame, or subsequent frame, depending on how we use it. Whether we're using a fixed update or an actual update or a post update, we can use any of those three. So it depends on whatever we now want to use all of this setup attributes or properties that are already set up for us within the application logic itself. So that's basically what we are doing in this case. So we can see 2D setup, the camera is set up, the tone mapping map face is set up. You don't really need to understand what all of this are. Like when you need them, you find out what they do. It's more like you saying that, oh, you want to learn how to drive. You don't really learn how to drive until you actually need it. You don't want to do that when you're 4 years old, right? You can learn that if you have spare time, but then it's only just what you need part time that you learn. So that's basically what we are doing at this point. Also, we are learning what we need for this time. So when we get to the point where we need more of these features, right? Probably are trying to implement something. We can do our research and say, okay, how do I do this? Then find out how to do it. And then if you understand the makeup of Bevy and how it works, we can plug it in, because remember, everything is pluggable because we're using the ECS, which is the what's the name again? The builder pattern, right? So that means you can remove anything, you can change anything to whatever it is you have, because everything will run in parallel, except you explicitly define it not to do so, like we did yesterday also. So we understand that all of these things are, yeah, they're important and they make a lot of sense. Now, the first thing you're going to notice here after this spawn, right? Back to the code now. Is after spawning this, after using the command, which is coming from commands, and we spawn this, we spawn the camera, spawn the camera to the tone mapping, the bloom, the band data, and all of these things. Now you understand what this is. This is what causes the gradients, which cause the banding. This enabling bloom for the camera. I don't really know what the bloom does, but we can find out eventually as we go. Like I said, I don't really know everything here too, but we know that once you need this, you understand what it is. So it says applies a bloom effect to an HDR enabled 2D or 3D camera. Bloom emulates an effect found in real cameras and the human eye, causing halos to appear around very bright part of the scene. Exactly. So let's look at the example here. We should see the bloom in effect. I think it's all of this. All these soft, shiny layers around it is what we refer to as the bloom. Now let's test this out first of all. We can test it to see. Let's see if you use W or S. Okay, I get this now. So you guys kind of see what is happening here. So all of these bright colors around it, I think is what is causing, is what the bloom is all about. So we can increase intensity or reduce the intensity of it. We can use Q and A to increase the intensity of the bloom. We can use a low frequency boost. We don't really need to understand all of this now because these are view designs. These are things that people specialize in mostly, like for creating um, words. When you're building like words, and then you want to there's a name they call them. What they call them now? I can't remember what their name, but they have like an actual name for people that do stuff like this, create lighting and other things that relate to the lighting. Is it production managers or something? Can't remember their names now, but that is what it is. This is exactly what we're talking about. So, like I said, we don't need to understand everything for now, but we are going to do something. First thing we do here is we spawn the sprite also, right? After spawning this, which are like a lot of initial things we need, we also spawn this asset, the image asset. Now we define that as a sprite because the sprite is also a struct, right? And that is to be rendered to a 2D camera. So we define that as a sprite, and then we load the assets. This is how to load the asset here. Asset server. Asset server is coming from here, which already added as a parameter to set up. And you can see it's coming from the asset server. And if I'm to guess correctly, it's also a struct, right? And as you can see here, yes, it is a struct. So that means we are using that as a resource. Remember we talked about resources yesterday. We can use that as a resource, but we are borrowing it here, right? So that means we can only read this, we cannot write back to it. So we are borrowing it, we don't have access to it, we don't own it, we are only borrowing it. If you remember the borrowership and ownership pattern in Rust, this is exactly what it means. So you borrow when you read, you are own when you can write to it, and stuff like that. Basically, let's just leave it at that for now. All right, so back to this. We have this asset. We currently don't have this asset for ourselves, right? And if you can see, there's this bird here in the middle of the screen, which is this one. We can create it ourselves and save it, and we can make use of it. But we are not going to do that. We just leave it and let it, and it's going to give an error, right? Because we don't have the actual bird, but then it's for explanation purposes. And then we can find the color for the bird, right? Or a color for the sprite we are creating rather. And it says the color we define here is sRGB, which is 555 for RGB, which should be a bit like a bit white, but not fully white, like more like an off-white color. So put something bright in a dark environment to see the effect. Yeah, so that's what it is. Then we set the size for the sprite, and the size for the sprite is defined as a vector 2. Is a vector 2, and vector 2 basically is just a struct to a two-dimensional. So we are using that as a two-dimensional, but just we splat it, right? Splat here vector with all the elements set to V. Like I said, all of these things, when you need them, you find it and you use it. And the reason why we're in the example here is so that you can be familiar with it. When you're familiar with it, you can now think of, okay, so I can use this for this, use this for this. You should be familiar with what environment or what world you are going into before you jump into creating stuffs. So that's the essence of this also today. So the next thing we do here is, after creating the sprite, which is the bird, we create the circle mesh, which is this guy. This one by the left is circle. So we're going to create three things here: the sprite, the circle mesh, and this is what hexagon, right? Yes, the hexagon here also. So we are going to create all of this. So that's the next. So the circle mesh here. So let's try something. Let me copy the other ones. We are going to be making some changes here just to show you guys what we mean. So first thing we're going to do is I'm going to copy this update bloom setting, because this is what we want to render per frame, right? And if you guys remember what we did yesterday, let me just copy the entire thing. Remember that when we use the updates when we add updates on our system, we are simply saying that render that once per frame. literally. So this is going to be rendered once per frame, and that is the bloom settings. That is what is actually displayed here, what we see here on the screen, because this is rendering multiple times per second, but it's rendering so fast that we can't even tell if it's rendering it. That's how it works. So in this case, we have the update bloom setting, which is what we have added to the update scheduler, right? So if we run this just to test it out, let's run this. Like I said, the bird doesn't exist, so just note that. Oh, it's still running Bevy. Okay, I forgot to add this to the main. So yeah, it's still going to be running Bevy. So we need to add that to the main, but currently we are not using the viewport now. We are using let's import the mod. We have Bloom 2D, yeah. Bloom 2D main. So basically we are running Bloom 2D now here. Why the complaint? Oh yeah, we need to make it public. Forgot to do that. So making it public just simply means we go back to Bloom 2D, add PUB to front of the main, right? That's basically what it means here. So if I do this, it should still work. So but adding it to crate simply means that you are making it accessible for all the packages and libraries wherever within this crate. So when you talk about crate, you are really referring to like the entire project itself, because we call libraries and other packages in Rust crate. So that's why the crate is here. But still, if I leave the pub, it still works fine. So let's try running this now, because that is the only thing we are initializing here. If we do that, we spawn this, it's going to spawn this actual thing we see here without the bird, because we don't have the bird. So if it doesn't throw an error because of the assets, oh yeah, you can see the path not found for the bird. Yeah, that's the error, but it doesn't still stop us having the window displayed, right? And so in this case, what can we do to tweak it? I want us to tweak some things here. I want us to like make adjustments. And making adjustments here is we go back to the Bloom tree. We're going to remove some of the things we don't need. For instance, the circle. If I remove the circle, for instance, let's say I comment this out. And it's supposed to run automatically. Why is auto reload not working? How do I activate the auto reload? Did I even think about that yesterday? I didn't set that. It's supposed to work automatically, I guess. Okay, but notwithstanding. So let's check it again. Now that, because I successfully removed the circle, you can see that there's no more circle here. All I did was just to remove it from the spawn. Simply means that there is no circle being spawned on startup. So that means if there's no circle, there's nothing to attribute to the circle. There's no attribute, there's no property to attribute, there's no function, there's no operation, there's no action basically to implement for the circle that is not created. So simply put, to do this, to hide the circle based on what we just did now, you can see that literally removes this and it works, right? It simply works by us commenting that out, and it didn't affect any other part of the code. Why? It simply means it was not spawned on start of the game, right? So most you can look at all these spawn as things that load when you start a game. It's light, you will see things like loading assets, loading graphics, loading all of those other things. They won't even tell you what it is, but just know they are loading stuffs. In this case, that's why the assets that we are loading happens on the spawn, happens on setup, right? And it's being spawned also as a sprite. The other things that we need are being loaded into the program, or into the app rather, on startup. And that is what is happening. So we removing that simply means there's not going to be any circle anymore, but we want to put the circle back to it. Now, remember that how do we add the circle? For yesterday, we added it in a different way. We added a rectangle yesterday when we did that. Let's go back to when we did that to show you guys. We created a rectangle. Okay, we created a circle first of all by using gizmos. That was the first thing we did. Right? We used the gizmo to create a circle 2D, and we created the camera. Let's look for red. Red, yes, this is it. So we created that using mesh 2D also to create the red camera that you see when you talk about when we consider the viewports to word that we implemented yesterday. We know that there's this rectangle we created, and this is how you create it. So just to make it easy to understand, whenever you want to create a shape, basically what you want to use is a mesh 2D. So what is a mesh 2D now? Basically, a simple definition of it is just okay, first of all, is a component, which means it's a struct. right? And that is what you use to render basic shapes. Like if it's the 2D version, the mesh 2D is what you use to render your basic shape in Bevy. Things like circle, square, rectangle, like we saw yesterday, rectangle. Today we're considering a circle. So that's basically why we use them. So just know that we use the mesh 2D for implementing basic shapes. I mean, when we say mesh 2D, we are talking about 2D objects now, 2D shapes, right? Basically. So looking at this, a complement for 2D meshes require a mesh material to be rendered here. So in this case, you can render a circle, you can render a material, right? If you want to, all of those things there. So yeah, this is the first thing. We have this here called mesh 2D dot add circle. Now let's do some other tweaks just to know if what we do here makes sense. Quick question: do I need to find out why this does not reload? Because it's quite important. We don't want to have to be writing everything at the time. Let's see. Auto reloading, get instant feedback, which is like restart or compile. Exactly. So I can auto reload scenes, textures, and meshes. So why is it not working? Do I need to set something? Troubleshooting. Auto reload doesn't work. Okay, no, not that. Auto reload. Sorry guys, just I want to make sure this works so that we can be faster. We don't need to like wait, reloading, rebuilding every single time. It's one of the features that Bevy has, so it should be working. I'm surprised it's not currently. Something break. Not sure. It's not supposed to. All right, let me just do this. Let me do a bit of asking just to be sure. Let me do a bit of asking AI to be sure that this works. Oh sheesh, I don't have any. Okay, I don't have any of this here. Let me install one of them that I kind of use all the time. Let me install a plugin. Yeah. Okay, still installing. I think when it's done, I have to restart. I don't want to restart this, but fine, that can be done. So, first thing to note here is it's not all right. So let's review this. Let me remove this. I want to show how all of these things pieces are together, because if I was simply explaining one by one or writing the code myself, I have to show you that okay, when I do this happens. So this case now, the code already exists for us. So rather than rewriting it, I'm just going to copy it and show you where all the pieces come together. Move the mesh 2D here. Remember we said the mesh 2D is just a struct, right? A struct that takes in what a parameter of the mesh that you want to implement, right? And then this is a pointer to that particular mesh. And then you add the circle to it. Now, this adding the circle here, if you consider this example here, you can see the mesh is here, is an asset, this is a resource, right? And it's a resource of a mesh. So let's look at it. If you look at, consider that from here. It's this. So the 3D object made out of vertices representing triangles, lines, pointers, all of those. So that's what we refer to as a mesh, and that's why we can use it to create the shapes that we are talking about. We can use it to create the triangles, the lines, the points, and all of these things, all the other stuffs. So we use it for both 2D and 3D representations. So that is very important. So when we talk about the 2D representation, we talk about the mesh 2D and material 2D, or mesh 3D and material 3D for 2Ds and for 3D, for rendering 2D or 3D respectively, right? So basically a mesh is just a 3D object, or let me say it's just a representation of triangles, points made out of vertices. So that's basically what it is. So you can look at it like a glorified vector, something like that, but it works. That's basically what a mesh is. Can I use client now? I think I have to sign in first. I'm not entirely sure. Oh, wow, I didn't need to sign in. Okay, that's cool. So let me ask this. This project, this project uses Bevy. Why is the alt reload not working? It should work when I make a change to the code, right? So this is what I'm expecting it to happen, right? And so let's do this cargo run. So if I run this, it's going to render that. And if I make a change, I'm expecting it to render it because of the auto reload functionality. Now the circle is back. So what I want to do is this. Let's remove this mesh. Let's remove initializing of the mesh to the from the mesh from the spawn it's created earlier. So let's remove this. No, don't do anything. No what reload features, need specific features to enable what reload. What features do you need? I need to understand. So basically this is what we have. So we have this mesh 2D and the circle. Okay, it says I need all of these features to use the alt reload feature. Wow. I need all of these features. I'm not on Linux. Okay, fine. Just this, but I'm not using that. File watching. Oh yeah, exactly. So it's the file watching we actually need. Cargo watch for automatic rebuild, cargo install, cargo watch X run. Okay. I don't want to use cargo run. Cargo watch here. All right. So basically, we'll stick to this for now. Let's just show it. So if I should display this, let me close this. I've made this change now. So I'm going to rerun this. So I'm going to rerun this, right? So I commented this out just to show what's expected to happen. So I'm going to rerun this just to see what you get. Now you can see that the circle is no longer there, even though the other things are there, like the material is there and they transform. But if you think about it, everything depends on actually creating the mesh at first. So that means for you to render a shape, you know that you need a mesh first of all, and then you need the material for giving it the properties of styling. Remember, the mesh material is where we style the that we displayed for it. So if you want to, we can color here, making it with 2. Now doing this or recompiling this now, or let me say, yeah, recompiling this program now. What do we get? We get a different color. We get a bluish, which is totally different from the purple we had before or the magenta we had before. Now, all I did was just to change this. So the transform is you defining the position. Now this is minus 200. Remember we said we are defining it as a 3D vector here. We really don't need the z-axis. I'm sure we can define that with 2D vector too, and it works. But then if you are using the 2D, we don't need this one, and it still works, right? Yes, but we need to define that as a 3D because they expected the 3D from translation, so we can't use this 2. We need to use the 3. So we need to take it back here. So does that make sense? That's basically what we have. So now this transforms a 3D. Okay, this works for just 3D vectors alone. So now this is minus 200. If I minus 20, for instance, what is going to happen? Because think about it, minus 200 on like this. We're referring to something like this. I will talk about x-axis. Let's say this is our arrow. And what am I doing? So let's say we draw a shape. No. So let's say I draw a shape. What is this? This is terrible. All right, so let's say this is my y-axis. Let's move this here. Right, if you talk about axis now, I'm just trying to explain what that is. So for axis definition, let's say we have something like this. This is my x-axis. And this is my y-axis. And if I want, I can actually add two of them together. Now, that means I can also extend this by duplicating this. And this is possible, right? And also I can also duplicate this also and make it this way. And it also works like this. So this is the x-axis, this is y-axis. So this is y, this is y. Let me write a text here. This is positive y. This is negative y. This is positive x. And this is negative x. So this gaming is just basically working with vertices and graphs and points and shapes and triangles and mathematics, basically. So this is what we are talking about. So the x-axis. So if you're talking about the minus 200 here, it simply means you are moving it along this direction, right? But I've reduced it from minus 200 to minus 20. So let's check what we have again here. You can see where it is currently. You can see where it is. See that it is close to the face. Let's say start from the F of the face. Now let's try reloading this and see. You can see that it's no longer close to this area. It has shifted here. So it simply means it's starting from where? Starting from the center of the screen. Let's assume it starts from here because it's actually starting from center of the screen, then pushed for far right. So now if I change it back to 200 and I make it 400, for instance, it's going to be way closer to this place. We can do that. So now let's reload this and see what we get. Like this, you should have an idea of what is expected to happen automatically. Yeah, it's moved here. So you can see that everything we created is just creating a piece and adding a piece to it, a piece and adding a piece to it. And all we are doing here is just writing Rust. We are not writing any other thing to make it work. And we are rendering actual graphics, as you can see from here. So this is exactly what we want, right? So I'm going to leave it like this. We're not going to change this. I'm going to leave the blue color and this particular location. And then the same thing happens to the hexagon, like we said. The hexagon also is the same thing. It's just a regular polygon that was defined. But how many sides? 6 sides. If I define it as 7 sides, it's no longer an hexagon, right? So let's do that and see. Currently, there are 6 sides to it. But if we change it to 7 now, it's going to have 7 sides. Change it to 5, it's going to be exactly, you can see 1 2 3 4 5 6 7. See how easy it is to create that. So if you want to create basic shapes, you understand how to create a shape already. We use meshes to create our shape. We add the shape we want to create to it, whether a circle or a rectangle or a polygon in this case. You can see all of these are also structs that you can create. So if you look at it now, you can see that structs are a major part of Rust itself for whatever you're trying to implement. So whenever you want to make reference to any Rust documentation, you should give more attention to what struct is and how it works, because almost everything you do will relate to data structures and grouping different structures together or different data types, and struct in Rust gives you the ability to do that. So that is exactly what is happening here. So continuing from here, let's change it back to, I'll leave it at 7, right, because we're making changes. So let's look at the next thing. What was the next thing that was spawned? Now we've understood different thing that was spawned. The first thing that was spawned is what we saw, the sprite, because currently the sprite is not there because we do not have the bird, so it's not there. And the sprite was not transformed in any way. There's no transformation happening on the sprite. If we decide to transform the sprite from where it is to probably a different location, that is entirely possible. You can define something like okay, because we can't use the sprite, I don't know what value. You can see flip one of this. This is all of these fields are defined on this sprite struct, so that's why we're able to use it like this. So but if we want to do it also, we can define a transformation to this, but we can't even see it, so there's no point doing that for now. But then the hexagon, we've seen that, we've seen the circle. Yes, now let's look at the next thing, which is the UI. Now what does the UI say now? In this case, the UI is just a text. Do you understand? We can spawn the text too, which is exactly what we have here. All of these things you see here, we are spawning them because they are tests. So how did we do it? We created a position type. So we created first of all a text. A text as a let me call it. I don't want to call it a node because there's an actual node also node struct. But a text is also like the circle, the mesh that we created earlier. So what you can do is you want to render a text to a particular screen, or you want to render a text in a UI. What you do is you just say things like, okay, you import the text, and after importing the text, you can just spawn it. What does spawn? Text or new hello. It will automatically render this. You can then style it with the font you want to use, the size, the color, and every other thing. Now, text with justification, you can decide to justify center. Remember when I told you that it has the CSS tailwind like syntax? This is exactly what I was referring to. So you can style it the way you want. You can animate it if you want to. You can do whatever crazy stuff with it. Makes a lot more sense. Yeah. So you can create an animation. You can create something that actually takes in a text, right? Maybe as input from the user, and then animate it on the screen, create it in different positions. Just randomize all of those things. That is something you can create yourself using Rust, and rendering that for maybe you can create that for your leisure time just to like understand how this thing works. So that's a possibility. So the next thing, looking at this now, we have what exactly is the next thing? We have okay, yeah. So we have text, we have the node. Now in this case, which is node, we have the position type to be absolute. We have the top to be 12. We have the left also to be 12. We moved it absolutely to this position, top left position, which is top left. Basically, what we did, and so that was what we did. And that's why we have the text. So you can call this the UI text to make it more explanatory. That's it. So that's exactly what happened for setup. So you can all understand now what happened here, where the logic of displaying all of this started from. It is just at the spawn. Now let's now give them their actual values. Remember, we just spawned them, meaning that we just gave the instruction to the app that okay, I'm going to need all of these things, fetch it and make it available for me. Now I'm going to populate them with what I need, which is where we are going to. So now I want to update the bloom settings. We need the camera, the text. Remember, we make reference to all of those things. Then the commands also for what we spawned earlier. And then we need the key code to be able to control some other things using the keys on your laptop, on your Mac, on your PC, right? So that's the second thing. And then we have the time. Timing is just to like make changes to the frames and all of those things. So we started with the camera itself, which we defined because we already have the camera coming from the okay, this is a lot. We have the entity here, a single entity, tone mapping, an option for bloom. Okay, all right. So basically, if you are new to Rust, and the option is a very popular syntax in Rust, is an enum, is an enum. So it's central to the other ones are central to Bevy, which is the single that for you. Now what that does is provide access to a city component, much like single, right? So what you want to do is, if you want to have, as in this example, we have a structure bus, right? And you want, it has out. Now you want to alt the bus. Let's say this is a game, and then you have a function called alt. Maybe you punch the bus or something, and you have a parameter for the bus, which is where you pass the bus instance to be able to undo it. What you are simply doing is here is get me a single field from this struct. So it's going to do a check. It's going to do a check, right? It's going to do a check to be sure whatever. So which is why we say that it is again. So it ensures that this is available for you to use, right? And then tells you that you can use this, meaning that it only contains one single element. So that is it. So you are using option if it's 0 or 1, but you're even using single if it's just 1, right? So that's exactly what we are trying to do. So in this case now it contains just this. So we are simply saying that yes, it contains a single field of this, then use that for the bus, basically. So that closes out this. So now let's look at the next thing and talk about this. So let's look at all of this part also. We are not going to look at it one by one here, but we are going to take a look at what we can add to it to make it a bit more interesting. So remember we said we are building a game here, right? And then we are using it to make sure that we can understand what is happening. And then if you want to tweak or add more things to it, we can. Just like we've done already, we've added the color to it, and we've added the direction to it, the colors, and we've changed the shape. We change this from this to this, and let's even increase the size of this. Let's try doing that first of all before we proceed. So the first thing we did here was to make it by 200. Here, I don't want the circumference radius to be 100. I want to make it 200. I want it to be larger than the circle. So what I'm going to do is I'm going to reload this, and then it's going to bring it back again, rendered as a bigger polygon, as you can see here. Makes sense? Exactly. So these are the certain tweaks that we can make because now we understand what is happening. So let's go back to the update bloom setting. The update bloom setting, first of all, started with the text, right? Because we want to render the text. Remember that we just spawned the text here by telling it we are going to need the text, but now we need to define what the texts are going to be. So the first thing we do here is we create a match. A match in Rust is just a way of defining a switch statement in JavaScript or TypeScript. That's what a match is. So you're creating a match and say that, okay, for the match I'm creating a bloom. Now the bloom, I'm creating a bloom and I'm checking that the bloom, I'm defining the bloom instance, right? I'm matching bloom. Now, where does bloom come from? Remember, we are structuring bloom from the camera because we are checking the bloom from here. So we are checking that and saying that, okay, we want to modify the bloom. Remember I said the other time when I made the update that if I press any of these keys, we're actually modifying the bloom. We are modifying the intensity, the frequency, the high pass, all of those relate to the bloom. And that is what we are trying to do here. So we are matching the bloom itself, which we've already spawned. Remember, we spawned the bloom, so we have access to that bloom now. So we are spawning that, we have access to it, and we are simply saying that, okay, give me the bloom, right, and match it against any of this thing. So the first thing I start with is I create a text.0, which is equal to bloom toggle space, which is what you see here on the, yes, you can see bloom toggle space is the first thing. So if I toggle space, for instance, you can see that the bloom is off. Toggle it again, the bloom is on. So you can see what I was talking about the other time about the bloom. So the bloom is that intensity that makes it look like light, like actual light. So you can increase intensity. If I press Q, for instance, or A, you can see that I'm reducing the intensity of the bloom. If I press Q, I'm increasing the intensity of the bloom like this, you see. So it's more like I'm creating a light source, and then I'm defining what is on the light source. Do you understand? Like I'm reducing the volume, increasing the intensity, rather, not the volume, intensity of the light source. That's basically what I'm doing here. So that's the bloom. So toggling the bloom, there's nothing else to do except I press O, which is the map face, tone mapping rather. So you can see the tone mapping is just creating random colors for you, not really random colors. We are actually implementing filters on them. So now you are beginning to have an idea of how to do all of those things. So let's say you are creating a scene now, for instance, and your scene requires you to have a light source, right, that shows like a very bright light source, like a bulb or something. All you can do is you can use the bloom to create something like that, and you can see that here. By what I've just done here, you can see that. You can see. So all of these are just things for the bloom. So that is exactly why the match is on the bloom. And there's a lot of different matches. Why? Because almost all the functionalities we are talking about exist for the bloom. Now, I'm explaining all of these things because I understand what is happening here. Even though, like I said initially, I don't understand what the bloom does. But by trying to see and tweaking it, I was able to understand that bloom is actually more like the intensity of the light on the object that we created, or let me say, all the meshes that we created. That's exactly what it is. It's not something you can pick up. So when we talk about these things, like I said, even if you're a beginner, total beginner, this is something you can just spend time with. Like I'm explaining now, yes, to give you a sense of, oh, this is understandable and it's simple. And then what you do is to build your confidence is to pick it up also and try to understand. Read about it. If you don't understand, we'll be here again tomorrow. Feel free to drop your questions on the chat or any comments on any of the videos. I'll try to answer it, and that makes a lot more sense. So I think that's a lot more a more sustainable way of learning this. So it's not actually that difficult to do, right? And yes, I know it may take a bit more time, but yeah, it works. So let's go back. So looking at now, you can look at the match, like this case, like a switch statement, like I said in JavaScript, or you can look at it like an if statement in any language, but this is a special syntax for Rust, which is the match bloom. Then in this match bloom, you're matching any of them. So it says sum if the text does zero. Okay, so we define the text does zero first of all. Why? Because this is test, right? And if text does zero equal to this dot string push this QA intensity bloom dot intensity. We are pushing the string to it. So let me show you what I mean. You can see this. What this basically means is when I turn this off, right, you can see that it removes all the other things. When I turn it on again, it brings intensity, low frequency. That is exactly what is happening here. So do you get it now? So if the bloom is this, we are simply pushing all of these strings to it. We are pushing this, we are pushing the WS, right? And what happens when you do that? You are pushing this, and then you are displaying this string, Q intensity. The intensity is in terms in numbers, bloom the intensity, the low frequency boost, which is this in numbers, the text low frequency boost curvature in numbers. So that's basically what we are doing here. So if you scroll down a bit, you realize that once we define all of this text here, and then we are done with that, what's the next thing to do? We now begin to work with the actual functions. So if the key code you press is the space, what do we do first of all? We use the command to fetch the entity, right? We say command or entity. Now, command or entity is towards we want to work with the camera now, the camera setup itself, the camera entity. So we talk about the camera entity and remove what? Bloom. That's exactly what we did. So if you comment this out, and when I press the space like I'm doing currently to remove the bloom completely, you can see we are removing bloom. So that is exactly what this line does. So we are saying that when I press this space, when key code does just pressed is this dot space. Just press means we press once. You can see that there's another one called pressed. This is why if I press this, for instance, if I press down, if you run the same program and you press down the space, it's only going to work once. But if you work with the other ones like the QA, if I hold down QA, you can see that it keeps working. I'm not tapping it, I'm just pressing it down. You can see it becomes like a light source, like the sun, very bright. And then I can press A to reduce it. You can see it keeps reducing. Now the pressed is a way of like it's going to run continuously. It's not going to be like the just press that runs just once or that runs once per frame. It's going to be very similar. It's different. It's going to be different. That's what I mean. Not similar, but it's going to be different. So that's basically what we are talking about here, right? So that makes sense, right? So that is what this line of code does. It removes the bloom completely. That's the bloom instance that we've already created, or bloom generally, from the camera itself. So that means there's no camera operation. Bloom is totally removed from it. So let's say remember we added bloom. If you remember, we did this. No, not here. Sheesh. Okay, this what I just opened was the is the actual setting, the library itself. You can see this is bloom settings.rs, which is not what we are defining. We are not supposed to tamper with it. It is exactly what is in reader mode. That means it's not my code. It is actually from Bevy now. It's from Bevy. You can see Bevy process, Bevy post process from the library itself, source bloom settings, and all of those things. So yeah, so we don't need this. So what I'm trying to show you guys is when we created the bloom itself, which is bloom here, which we imported. So we are now saying here that remove it totally from the camera, from the entity itself, from the word itself. If I think about it by saying that remove it from the word, that is what it means. So let dt equals to, remember I said the time for manipulating things on every render, basically. So now we are going to start with the key A. So what does key A do? Key A is just taking bloom dot intensity, which is a property that exists on the bloom. Remember bloom here is coming from where? Here. And this is coming from where? Here as well, right? You can see this is coming from here, this is coming from here. So which is what we are destructuring from the camera, which the camera is what we are taking from here. Remember that we are picking entity, tone mapping, and bloom, which is entity, tone mapping, and bloom. And what we are doing simply is that we are removing it from the camera entity itself, and that's exactly what happened. But bloom itself has a property called intensity that we can modify when we press Q or E. So when we press Q or E, you can see that we subtract the intensity and we divide that time by 10 and keep adding that particular time division of by 10 to the intensity itself. So that's why you can see that whenever I press Q, it keeps getting brighter. The intensity keeps increasing. Whenever I press A, it keeps reducing. Like I said, it's just basic math most times. Everything that has to do with game development is not basic math, right? It is math. That is so it's just math. So yeah, so that's basically it. That's just all we need to talk about here. So that's that. So the next thing is bloom.intensity is bloom.intensity.clamp, which is so we are clamping it. In this case now, we are clamping simply means that we are setting a minimum and maximum. So we are restricting the value to a certain interval, so it can't be greater than that value. So that means that the reason why that is currently at 0.46. If I continue to press the Q, you can see it's going to 0.6, 0.7, 0.8, 0.9. You should stop at 1. It should not cross 1. And if I reduce it also, it should not go below. Now you can see how this appears like a moon and this one like the sun. You can see that particular thing that is happening here. So if you do this currently and reduce it from here, you can see that it keeps reducing until it gets to 0.0. So the clamp is just a way of telling it that, okay, you can see how it drops until it gets to 0. So that's what bloom does. So it just gives that light source. So exactly. So now in this case, now you can see this is keycode.press this. So we added a clamp to it. So that means whenever it increases up to this point, it will not pass this value, minimum and maximum value. So it won't go below 0, it won't go beyond 1. So that gives you like a restriction. So if keycode.pressed is S, which is for the low frequency boost. Now basically it's just the same thing. You can see we clamp that again, we clamp the boost curvature, we clamp the high pass, we increase it, then clamp it. Then the composite mode, we change the different composite mode. Let's say if you use the G, right? T or G. If I use T or G, additive. T, energy conserving.
It's 17 hours.
You can see how increasingly bright it is. I'm sorry if this disturbs you, but I'm just trying to show you what I mean here. Now you can actually see how this works. So that's basically bloom. So if I change it from the additive to from T to G, energy conserving, so it conserves energy. This one just adding it basically. All right, so all these are just filters, right? You can see. So it just is very basic. So everything that happens here is just more like an if statement. If, then also the scale. So let's look at the scale. You can the scale is when you press K, right? So there's a way to scale it, horizontal scale. So if I press K, you can see the horizontal scale for that. If I press I, the scale increases. So that means it's able to blend into each other by doing that. But if I do this, you can see that it blends into each other, but very small. Then at one point, it doesn't blend into each other. It becomes separate from each other. You can see what we're talking about. So that's the reason why it blends into each other in this form. Like the light here blends to this one is because of the horizontal scaling that we have. And then we also clamp it to between 0 to 16. And that's it. So now this gives you a picture of everything I've been talking about, right? You can see that it's not that crazy. It's not that complex, really. So, and then we set a none here that if you turn the bloom off, like but based on what I explained the other time, you can, so if you turn the bloom off, if the key code you press is space again, right, it's going to insert the bloom. But if you, just like we saw the other time, if you press the key code once, it's going to remove it. But if you press it again, it's going to show it. So it's going to show all of these other ones, like I said, if you press the bloom once, and then the value is what? Toggle space, basically. And then we push all of the string. That's for the text. Remember, we define the text. Text is coming from here, right? So we push all of that string that we have. We push it into we use the push string, which also applies to the tone mapping. That means if I do this, you can see it changes, 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 changes. That's exactly what is happening here. So if the key code presses key 0, which is what I showed the other time, for now making the last change, which is the tone mapping. So what we do is we insert the next tone mapping. And what does that mean? All this match also is what you pass. It's not more like a function calling a function, basically what we did. And you can notice that you can insert new things into the entity. You can see we inserted and we removed. So imagine a game whereby you can just click a button and something appears. That's basically how it is done. You can insert something into it, you can remove something from the word, you can insert something to the word. So this is basically everything you see here now is just Rust. Remember, this is just a tone mapping is what we talked about it as just an enum, and a enum that contains none is suited AGX blender this. We are not creating this, already existing by Bevy for us. We are just making use of them. So these are like tones, and then there are different tones. I don't know if this is all of them. I believe there should be more. Tone mapping. I think we've used all of them because these are like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So I think we've used all the 8 that exist from Bevy. Bevy already provides this, and we've used literally all of them. I think this makes sense, right? So now, if you try to understand what was done here, it might look complex if you don't understand the way I've explained it. The explanation now, it should look easy to you. To even add more shapes, I'm sure you can do that. You can add more shapes to it. Let's try adding a triangle or a rectangle somewhere and position it on the screen such that whatever we do affects it. So all we need to do is to create a circle. Let's create a rectangle. A rectangle mesh. Nope. Let's create a rectangle. Now, a rectangle is going to contain 2 things, not just one. It's going to take a width and a height. So let's call this 300. The height is 300, right? So we've created a rectangle. So what we want to do is we want to put it says put something bright in a dark environment to see the effect. So now we are going to create different colors. Let's give it a warm yellow color. And for us to create yellow, we need green and red, right? Or creates green and red, I guess. Yes. So green and red, let's call this 7.5. Let's give this 7.5, and let's give this 1 to simulate that effect. And so what we are going to do next is we are going to reload the app like we have here, right? And then let's rerun this and see. So basically now we have a rectangle, if I'm not mistaken, even though it's going to be on top of the circle basically, but we still have a rectangle, as you can see, yellow rectangle, and it's directly on top of the circle like I said, but we don't want that to happen. Now we want to do it in such a way that the width is 300, the height is 100, so it looks like an actual rectangle. Now currently with what I've done here, this looks like a light bulb, right? So let's say we want to make it look like a light bulb. I want to make it not 400 now. I want to reduce the height from this to maybe 100, or let's say 120, and then I want to change it from 400 here, which is the dimension of the position rather on the screen. So I want to put it on top of this circle. So what I can do is from the 200, I can add the height to it to make it 620. So that way it stays on top of the circle itself. Or I can make it 600 just to show you that overflow first of all. Then we'll talk about the being on the circle itself. So if I do this and then I go back to check it, you can see, oh, did I change this? Oh sheesh, no, it shouldn't be here. The y should be added to it. The y should be the 120, right? But let me make it 100 first of all. So that means it's going to be at the top of this 100 because the height of the circle, the radius is 100. So beating it 100 should make it be above the circle itself. So let's reload this now and see. Like I said, it's just mathematics, geometry. Yep, now you can see what I'm saying now. So this looks more like a light bulb, even though it's not exactly like a light bulb. And now it's also entering into here, right? Because it is there. So what I can do now is to make it like 120 to actually make it position on top of the cycle directly on top of the circle. So this is what we have. And now this is not a perfect light bulb here, but you get the idea. So if I reload this again, So the height is in terms of radius. Okay. Oh, what am I doing? Okay. Yeah, I think I get that. Okay, you can see 160. But we don't want it to, the reason why it's 160 is because I have to divide the circle by 2. I have to divide the height of the triangle by 2 and add it to the top of the circle, which is 100. So that's 100 plus 60. That's 160. So that's why I got 160 here. And that's why it's positioned on top of the circle. But we don't want it to be positioned on top of the circle directly. So I'll still take it back to like 140. So it blends into the circle itself. And there's a way to position it below. So it actually looks like the circle is on top of it to give it the actual structure feeling. But we are not doing that now. And besides, I can't even remember how to do that unless I have to check it. So I'm sure we are going to encounter it in another example. So doing that in another example should give us an understanding of what we are trying to do. So you see that this makes sense, right? And you can see it applies to all of them. The same thing applies to all of them. Everything applies to the entire structure. And all I did was just to create a particular mesh, right? A 2D mesh called rectangle, and that's it. And it works. Now remember, everything we have been working with here is just 2D cameras. So we are working with 2D planes, not 3D. So everything we are creating generally is just a 2D mesh and a 2D plane, and we are displaying it and we are showing it. And that's basically what we have. Capish? Yes. So that is it. So you can see how easy it is to like add stuffs, render anything with Bevy engine on top of as a UI. You can see if I modify this, it still retains the position on the camera. Still retains the position on the camera, even if I update. There's no creating viewport and everything because we are creating these things based on the viewport, and that's why you can see here everything we are doing is adding it on the viewport itself by creating that on the camera itself, right? Yeah, so yes, that is the example. So you can see how easy this is. And if I want to make it even a bit more reasonable, we can then change the color to 7575 like we have here. Change this to 75, change this to 7.5, and change this to 1, just like we have. So it give us that white yellow color. It gives us the yellow color to make it look like a light bulb, a white yellow light bulb. Right? And if you check it again, we're going to see everything should not be yellow, including the jersey. Now it gives us that bright feel, that yellow bright feel. So it gives us that yellow and green color. So looking at this, comparing this to the example we have that we just tweaked, you can see that it's similar. This is an hexagon we created. We added an right. We made it a hexagon anymore. Polygon, not a 6 size polygon. We created a circle, but we didn't use the actual colors, right? We used our own color that looks like the sun, and then we converted that to look like a light bulb, like this. That makes sense. So one more thing I want to do so it will look like a beaker is to make it to reduce the height from 120 to reduce it to like 80. So that means I have to tweak this. Remember, it has to be division of that. So I need to make it like 120 so that it doesn't stay on top of the circle directly. It's just mathematics, right? So yeah. So that is that. I hope you guys have learned something today. Like I hope this makes a lot of sense. Like, I don't want us to stop here today, even though I feel like it's reasonable enough, but we are not going to stop here. We still have other things we want to do. So transforming this, we can add other things. The transformation, I guess. This is translation. We can add other things like you can see rotation and all of those things. We can still rotate it. We can but we are not changing anything. This is fine for what we have. This is what we just created. So this is what we replicated from this. You can see. Now let's pick another one just to demonstrate. Now, like I said, we are going to be working with the examples, and it's very good to use that as a learning resource. So we don't need to write it ourselves, and then we can understand that now we've done this. Now imagine if you want to create a bird like this. We already know how to do that. We already know that we use the assets to import this bird and then we display it. Now, say we want to, I would like us to look at the CPU drawing, but for now, okay, yeah, I would like us to look at this because this works with pixels. So let's look at how this works. Now we might not really copy this into our IDE to like render because we've already picked one that deals with a lot more things, lot more graphical stuffs. So we might not use that. But let's look at what this looks like. So while this is rendering, let's see. This is refusing to render. Or probably it's taking a lot more time. But this is a bit complex because you can see a lot of mathematics here and a lot of flutes. So I think we are going to skip this. I don't want us to do this, but it's quite basic too. It's not too difficult. Don't allow this scare you from trying to pick it up because it still works. It's still basically the same as what we did. In fact, what we did earlier is a bit more complex than this because it has a lot more code. Yeah, but this is actually more complex though. Okay, this doesn't show, so I don't want us to dwell on the one that doesn't even render initially. So let's pick another one. Let's go to we already understand how to implement a mesh, so we don't want to deal with that. So mesh to deal with vertex color. So we can look at this. It's a bit more similar to what we just did. So after we do that, we can deal with the rotation. So say we want to create like all these games where you have a plane and then you move the plane, you can move the plane, you can move the plane, and then they show, they do all of those things, they shoot. We can implement something like that, right? All we just need is we need 3D assets, or we need assets, maybe not 3D, we need 2D assets. And we can implement a game like that. We can implement enemies, we can implement the the the, the, the airplane, which is the one we control with our keys. Now, this can give you an idea. But this should give you an idea already of what this can look like. This can be our world with this same background. We can create something like this as our background, and then we can layer the game on top of it. And then it just depends. You will have the text, yeah. We are just going to work with the text, the what's that? The code, the key code, right? We're going to be working with the key code instead. And working with the key code should give us the same thing. So in this case, it just makes a lot more sense. So let's look at other examples. Multi-window text renders text to multiple factor using both text and text 2D. So we'll come back to that when we need it. There are ways you can render 2D also and manipulate it, but we don't want to do that right now. So there's a move sprite, change the transformation with sprite. So that means we can move the sprite. It's possible. Mesh 2D repeated texture. So these are examples of what you can use depending on what you are trying to do. There are examples here. Manual mesh 2D renders a custom mesh manually with mid-level renderer API. So arc 2D meshes, you can create an arc, you can see. And this is the alpha mode for the mesh 2D. Then the move sprite. The transform itself of the sprite is now the reason why this is important is because mostly if you want to create a simple game like that want to move a sprite. Let's look at this. I think this is going to make it's significantly interesting. Let's look at the move sprite. So we can see how and you can see this moving here. Yes. So what I would like us to do here is we can make this work. We can move it from left to right. Now this is a sprite, right? But we should be able to move any other thing, even aside from a sprite. Now let's look at how the sprite movement works. There's a sprite movement here, right? We use the sprite position, we use direction to transform. Can we implement this thing, this direction that we implemented and the movement, this sprite movement? Can we implement it for any of our shapes here? We should be able to do that. All we need to do is to pick what they use for the transformation and what is being used for the transformation. Now, I believe it's going to be a transform to translation, just like what we've used here. Remember, we used transform from translation here, right, for the movement. That means we can do something similar that makes it move constantly. And how do we do that? We need to create a function that's a system that will be added to our add system here, which is going to be added to the update, and then that can work. literally. It's just something that we can do. So now let's try doing that. I'm not sure if this will work, but then it's worth a try, right? This is how we learn. So let's create a function that does this. We're going to call it a sprite movement. We're going to create a direction. I'm going to call it create a direction in num, right? Because it's an enum. You can see direction dot right, colon right. So that means the direction is a component which we are going to pick, and you can see it's an enum. So we are going to use that here, left and right. Then one more thing, what do we need to change again? Okay, that's all. But we are not done. The reason why we are not done is because if you consider this, we have the time, yeah, which is a resource of time. From the analogy I gave yesterday of trying to build a table, you need certain resources. You need a saw, you need a screwdriver, you need an hammer, you need a pencil for drawing, you might need a tape. Definitely you need a tape, you need a screw, you are probably going to need an hammer, you're going to need a screw machine, you're going to need all of those things. Right. So those are the resources. Time is also a resource to implement this logic. A sprite position we don't need now. Reason why we don't need the sprite position is because we're not working with the sprite itself. Now, this transformation for the sprite movements, where did we use it in this code base? First thing we are going to look at is where is it being used? Aside from being used in the systems, update system, so that it updates itself automatically, it's also being used somewhere, right, by transforming something. Now, if you look at what is being transformed, it is transforming. Where is the direction right is transformed or translation? Where is transform coming from? In sprite position. So that means we need to know the sprite position first of all. That's direction and transform, but that is only for the sprite. And you can see direction dot right, direction from XYZ. So we can move this and add something like this. Like I said, I don't know if this is going to work, but let's see if it's going to work. So you can add this to what we want to move, which is the circle. Let's say we want to transform the circle in our use case now. You can see no errors currently. We just did a transform dot from XYZ 0, 0, 0. Then direction is right. So initially when it is spawned, it's going to what move right. And if you consider that, if I reload the page, look at what happens first of all. It moves right, right? And then after moving right, that is the direction. It moves right. And the next thing that happens is what? The sprite movement is this. The sprite is animated by changing its translation depending on the time that's passed since the last frame. So this can be reused multiple times. That makes a lot of sense. So all we did is just to add this. So we need to add that also. Even though it's not sprite position in our use case now, we need to still add it to bloom, update bloom setting. So we are going to add it to what? What's the name again? Sprite movement. We're going to add it to sprite movement. We're going to chain it. The reason for chaining it, like we learned yesterday, is that we want this to run first before this run, because if you don't chain it, they can run in parallel, which is not what we want. So now let's see if it's going to work. Like I said, we didn't know if it's going to work. We just tried it. But it gives us a sense of, oh, we are understanding what is happening. We know where to add this. We know where to move this. We know where to remove it from. So even if it crashes or fails, we know that, yes, you see, it failed. Reason is because it says command Q has an apply commands been dropped. Did you forget to call system state to apply? And we can see where the error is coming from. Let's check. So, but it's still a good way to do this, even if it's not going to work. Now, looking at it, what's the first thing it said? It said bundle this, transform, as duplicate component, transform. Oh, I think I understand where that is coming from. So we have this. I think that's basically why that error happened. So let's try this. We can't be too sure. So we are trying, we are learning. Let's see if it works or if it fails again. And it works. And we can see that it works. So he actually created that and it moves on its own. And then that means we've been able to successfully animate the movement of our circle. That makes a lot more sense, right? All we did was just copy from another source, which is exactly what I'll be saying, that we can literally copy what we have and add it to something else. Now, the reason for the error initially was because we have double transform here. We have a transform from XYZ and a transform from translation, which doesn't really work for our use case. So it's a duplicate of the same, it's a duplicate of the actual structs in this case. So we don't need to duplicate the struct. So that's why there was a problem. So initially what we did was when we spawn it, we are saying move right. right? Automatically move right. And the moment you move right, now this is going to run on every keyframe. So that's this sprite movement. But the beautiful thing is that we do not need to map this directly to the sprite. We already did that by adding the direction to the circle itself, right? By defining the direction that's right on it. So it simply means when we started it, or when we started the application, it's going to move right automatically. So once it moves right, what's the next thing it's going to do? It's going to check the translation. It's going to initiate the translation by 150 for multiplied by the time that I've passed since the last frame, and then it's going to move like that. And then if it is left also, this is what is going to happen. It's going to move like this. So what does it do? How does it move left and right? If the transform or transition is greater than 200, it should change the direction to left automatically. So what does that mean? That means the sprite position that we are trying to get here, which means we are querying direction and transform for the sprite position, which is logo and transform in this case, literally, because the direction where we define direction on was the logo, but in this case it's not logo, it's just a name. We can change it from logo to circle and it still works. And you can see that we successfully created this that can be animated. And so now you see the power of Bevy, and you see what you can build with Rust, literally. So this is exactly what we've been talking about. So the examples make sense, they work for our use case, because this is what we are trying to do. It's not that crazy, it's not that possible to create, it's not difficult. Of course, we are going to get errors. Like I said, I didn't know if this was going to work, but we tried it and it worked. And you can see we successfully have something that animates. We have something that looks like the sun moving up and down. So you can create that. You can create two of them. You can create one that looks like this, that looks like the moon, and one that looks like the sun. Make the circle for the first one a bit bigger. Make the circle for the second one a bit smaller. You can increase the intensity, control the intensity, depending on whatever you want to do. It's just your choice at this point. Right. So this is exactly what we are trying to do. So now we can see we don't need to recreate this, because we already have an example that we can use. And if we decide to recreate it, we can simply create it as a circle and it works. Does this make sense? Right? I feel like it does make sense. So this is exactly what we are trying to implement. So yeah. So if you're enjoying this, please consider subscribing, and so that you don't miss out on the next video that is coming out. And if also you can give this video a like, so that it helps to boost commitment, right? Because there's a lot of things that I do too, but I think I want to do this because I also want to learn from it, as much as I'm giving out people that want to understand it. So I believe that the best way to learn is by building, and that's why I always try to build one thing every single week, different things every week. So that is the idea for this. So please and please, I really appreciate if you take this, give it a bit of more commitment, right? Like I said, it's not difficult. You see that we've already worked with two different examples today. We've done two different examples, and we'll be able to combine two of them together to implement something else, a new example. So that makes a lot more sense. So that means we are learning, and I'm very, very happy that that we are learning this. So let's look at the next thing. So we implemented what? We implemented the 2D bloom. Yesterday we did the 2D viewport to world. Today we did the bloom, 2D bloom. We implemented the move sprite, which is also an interesting part of what we've done. So which was what I wanted us to see, how to move the sprite. Now following that is we've implemented the mesh 2D. The mesh 2D is, we've already done that already. In fact, we've implemented different meshes. We've implemented the circle mesh, a rectangle mesh, a polygon mesh with different sides. So we already know how to do this. So we're not going to consider ourselves with the mesh at all. The next thing we're going to consider now is the pixel. No, should we go to the pixel grading? So let's consider which one we should do. Should we work with the rotation? I feel like we can actually work with rotation. We can implement rotation to this ourselves, even without looking at that. And think about it. How do you handle rotation? The way you can handle the rotation is we already have a transform on the rectangle itself, which is this. And remember I talked about chaining the other time. We can add rotation to it. So if I'm not mistaken, we should be able to rotate it by defining something on it. Let's see. Does this work? Okay, I might be wrong. We might not be able to add rotation to it directly. Okay. But it gives us this. So the rotation should work. Trade bond is not implemented for mesh 2D and quant. Oh, okay, that's a very detailed error. So let's actually look at the rotation. Since I'm not actually correct with this, let's look at the rotation to understand how rotation works. But before we talk about rotation, let's look at the other ones we can work with, like sprite animation. Now we've already looked at how to move sprite. Can we also implement how to animate something? Let's go bigger. We've already done something that makes more sense. At least we've been able to do this just today within the space of an hour and a half. Without prior knowledge, without prior understanding, we can create this and we can tweak the intensity like we did. We can make it brighter, we can make it dull. Looks like the sun, right? Like, I don't know if I'm the only one seeing it. It actually makes a lot more sense. And you can see that the colors actually blends in as it moves. I don't know if you're noticing that. You see, right? So the color actually moves. It blends with the world as it moves in. You can see when it moves out, it becomes a bit cooler, a bit darker by that side. That's by the left side. But once it comes into that viewport, it becomes warmer, like the way the sun actually works with it. So I don't this gives you that feel. It makes it a lot more reasonable. These are things you can play with to give yourself more confidence on how Bevy works. And trust me, this is just Rust. Like literally, we are not working with time with we are not working with traits. We are not working with macros. We are not working with lifetimes, right? We are not working with any of these complex things in Rust. And you can see how this is reacting. You can see how the light is reacting with the world. I don't know if you noticed that. All of these things are already given to us by Bevy. So you can build more complex stuffs, extremely complex stuffs, or let me say simple stuffs. It doesn't have to be always complex, but simple stuffs to work. So I'm quite happy with the progress we made today. So let's move on to something else. And so first thing I would like us to do, we already understand how to do this. I'm thinking we should look at the Bevy with vertex colors, but it renders a 2D mesh with vertex color attributes. Okay, I think we'll come back to this. Let's proceed with something else. So pixel grid snapping shows how to create graphics that snap to the pixel grid by rendering to a texture in 2D. Okay, let's see how this works. If you don't need it, you can always pick another example. Oh. Okay. You know what? I don't think we need this for now. Oh, it rotates, right? We can use the rotation. Like we talked about, we can use the rotation. Let's see if you can actually implement rotation using what I just saw there. Nope, nope, nope. There's something that was done then. Rotate. Is it just rotate? That can be it. That can be it. Oh yeah, exactly. This is it. All right. So, yes. Let's see. No, let's go to the actual one. Let's not deal with this yet. Let's not deal with the pixels grid snapping. Let's pick something for our level since we are growing. The more we need it, the more we pick what we need. Let's look at the rotation, to the rotation, to understand what to do. And this way we can actually build the game that I was talking about. Like you can rotate it, you can create a simple game that moves within the window itself and the world that which is the 2D world currently. And we can see how that will work. So basically what we are trying to do is this demonstrate rotating entity to using quaternions. Okay, so which was what that was giving me as auto suggestion the other time, but it didn't work. So this is everything here is similar. The setup is always similar. You load something, you spawn something, text, the camera, the sprite in this case, and then the sprite for other things. But in this case, just the sprite that has been spawned. But in our own use case, we are not spawning the sprite because we don't have access to the sprite. Why is this taking time to load? Okay, if it doesn't load, we can still pick it to implement the rotation ourselves. I'm sure we can implement the rotation. So let's see. Where did they implement the rotation? So I'll probably prefer if you copy this and then try to implement the rotation itself. But that means we can still make use of it in another way by using this transform. So it says update the ship rotation around the z-axis perpendicular to the 2D plane of the screen. So which means we need to implement transform the rotate z. So it just doesn't work like that. Wow. Okay, so we need a bit more logic to implement the rotation itself. Okay, I'd like us to do this, but then we don't have the sprites, we don't have the assets. And it will have made more sense because this looks like an actual game that we can see how it works. You can see the ship handle, the enemy B handle, and you can see the movement. Snap to player system. Then get the player transition in 2D. Then rotate the player. Okay, maybe we can use the quad actually for the rotation if it works. Okay. I wish it's going to display here so we can see it. Let's check the web GPU. Oh, so it works for web GPU. So you can see what happened initially when we reload the page. It automatically rotates. Now you can see what is happening. You can see how it's moving with respect to it. You can see how it is moving with respect. So that means it's actually snapping it to grid. I don't know if you understand what is happening. So the snap to grid that we changed the other time, I said we're going to come back to. This is a more reasonable version of that one. So you can see what is happening. Whenever it goes to close to it, any of the, in fact, not even close to any of them, whenever we move in any direction, the ships kind of like follow the cursor itself. You can see all of them move with respect to the cursor in terms of whatever direction, whatever axis it moves to. Let's see if it can go out of the viewport. Okay, it doesn't. That was a good check. You can see that the ships follow it extremely well. So now let's try to understand what is happening here. Here, the first thing is a plugin was added. They added a resource. They added the system, which is the setup, added systems, player movements, snap to player systems, rotate to player systems, which is interesting. So this is auto rotation based on another resource rotation. Oh, this is cool. So this is another cool one we can tweak or work with or interact with just to understand what is happening. And it makes a lot more sense. So what can we do in this case? We can check from the examples on GitHub and copy the assets. Okay, we need to actually download it. Oh no, it doesn't work for me that way. Okay, so what we can do in this case, just try to understand it. Now, since based on the understanding of what we have, right, for now, you can see the setup is same as the other things we've done. We have the spawn for the camera. We spawn the text. That is this text that appears here. Remember, we have to give it a styling also after we spawn it. Spawn the position to be absolute. We spawn the top left to be top left. And that's for the text. So we also need to spawn, remember we need to spawn the camera so that it's prepared. We need to spawn the text so that it's prepared. Now the next thing we need to spawn is we need to spawn the ships. And how many are there? There are 5. Right? We need all of this. So we need to spawn all of this 1, 2, 3, 4, 5. So what do we do in this case? So web GPU is actually quite expensive. It's actually making my laptop shout. Wow, that's crazy. And if I render the web GPU, it doesn't work. It refuses to work. This is making my laptop shout. Okay, let's go back. Go back. Computer stop. Okay, let's see. It's fine. So now let's continue with this. Like we said, we already understand the basic setup we always have, and then in the setup we also spawn the ship, right? Player controlled ship. Now the player controlled ship is this one in the middle that we control. That's the ship, not the enemy ship. So that's the player control ship. Now for the player control ship, there are okay, there are two types of enemy ship. There's one that have this by the side. There's one that have the strong. Okay, that makes sense. I was thinking where would the other one came from. So for the player control ship, we have that's the ship handle. So we spawn the sprite from image, which is our ship handle, which is what we've imported here. We've loaded it, the asset server dot load. So we loaded the asset. We have the player. In this case, player movement speed is 500. That's meters per second. Then we have that's the movement of the player itself, the player ship. Then the rotation speed is flow 32 to radian 360. So I mean 360 degrees per second rotation speed. Then the enemy that snaps to face the player's pawn on the bottom and left. Enemy that snaps to face the player's pawn. So what does this mean? The four enemies ships that are displayed, right? We need to also spawn them. So that means we need to load them from the image as well. We write sprites from image, enemy a handle.clone, which is also what we do. Transform the same thing, snap to player automatically. Then command or spawn, also sprite from image, enemy a handle, perfectly defined. Then transform from XYZ, 0, this. So basically, this is just positioning it, right? Remember, the horizontal margin in this case is coming from where? The bounds. The bounds of x divided by 4. Bounds is coming from where? Is a vector of 120 by 640, which, if I'm not mistaken, is the definition for this. So we are saying the bounds divided by 4, right, is the horizontal margin just to get the position they are going to be on screen, which is what you can see here, 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 and here. So that's basically what we have. So after we define that, we now have okay, so we define the horizontal margin, vertical margin for the 4 of them, horizontal and vertical. So we have the rotate to player, rotation speed, which is degrees per second, rotation speed for the rotate to player also here for the struct. We have the transform from XYZ, which is vertical margin, and this we've already defined. So that means for the first enemy handle, we define the first one as to have the vertical margin, the horizontal margin, and the vertical margin. So that's why you see the first one has it here. There are different type of ship. One here, one here, one here, one here. This and this are the same. This and this are the same. So that's why we have spawn A to be the same thing. A and do, horizontal, vertical difference. So and the same thing happens. Now the player movement now, how do we implement that? The player movement system demonstrate applying rotation and movement based on keyboard input. So that means if you need the keyboard input, we need the key code. We need that, and we need the time to be able to update it for every keyframe. And so we need to also the query to be able to get the player and the transform. So that means the player is already defined as a struct, as a struct, which that means is a component, right? That's a player, rotation speed, and this. So we have the snap to player, which is also a struct. That means it's a component. We have the rotate to player as a component also. So what we need now is we take the keyboard input and the query for the player and the transform. The transform is where we are going to be handling the rotation, if I'm not mistaken. So that is why we destructure this query into shape and transform. That means the shape is the player, right? So we destructure it with this and this. Then the first thing we do is you take the rotation factor to be 0.0, movement factor 0.0. We initialize it to an initial value. So when we press the left arrow key, just like whenever I press the left arrow key, the ship moves. You can see what happens. It rotates. It rotates from the left. So that means the rotation we are trying to implement, we are almost there. So now you can see how we are breaking this down to get what we want for our own code, right? So the next thing we need is when we do that, we trigger the rotation factor by 1, literally. So where does the rotation happen itself? This is where it happens. Transform or rotate Z, rotation factor, rotation speed, time delta. Let's see if we can implement it here. But we can't do transform here because we already have that. It's going to fail if you call under transform, just like it failed the other time. Oh, basically because it's different, it might work this time around. Let's test it out. Rotation, rotates. Let's see. We have rotate Z. Okay, rotate Z. Let's see. It's telling me to expect what? Takes 2 arguments, but 3 were supplied. Expected mute transform but find F64. Oh, so it has to be immutable transform because we want to actually update it. Yeah, that makes more sense. Okay. So that's why this was created this way. It's actually a mutable transform reference. Whew. Okay. So we can't do that on it directly, except we change what the transform is. And currently, if you look at this place, transform is mutable when we query it here. Considering this place, you can see transform is mutable, so we can implement a mutable reference on it. But from this place, transform is not mutable. Where is it? Yeah, transform is not mutable from here in any setup, in any way, because we are not querying it at all. So transform is not mutable because we are not even importing it anywhere. Neither are we using it. We are just using a transform that comes directly, just like we have from there, just directly. Just like you see, the same transform the XYZ that was used there. Now, these also are not like that. But here, if you are querying this, you can apply the transformation on it for every update. So let's say, rather than defining it on the mesh, on the spawn itself, we don't want to define it on the spawn. We can define it on the update bloom settings, for instance, so that on the first keyframe or on any keyframe, just like the way the sprite moves. In fact, we can define it in sprite movement actually. Let's see if we can do that. So we can define it on the sprite movement and we can transform it by transform 2D, which is also, in fact, it is perfect here because we already have this. So what we can do is we don't need to do that inside the for loop. We can say transform. Should I destructure that? Is there any need because it's already inside here? I don't want to do that. What if I just do it inside here? Because now I'm already taking respect to the sprite position, because that's where the query destruction. So this is already destructured here. So I can say transform the rotate Z. So transform the rotate Z is going to takes a parameter, but 0 parameters were supplied. So transform in what direction is my question. So it's going to be transformed in rotation factor here is this, which is based on the keyboard press. But in this case, I don't want it to be defined based on the rotation factor. I just want it to be defined by, do I need the time delta too? Okay, let's try it out. Let's see if we have successfully implemented the transform for our functions. for our current application. Okay, we can't know if it's transformed already because this is defined on, what do we want to transform? The rectangle. Yeah, we want to transform the rectangle. So that's the easiest for us to know if it's transformed or not. So we said update the shape rotation around the z-axis perpendicular to the 2D plane of the screen. Okay, this is a problem. I understand what this is. The sprite movement only works for that, which is not what we want. Oh, yes, okay. Understanding when we did this for the player shape, when we spawned the shape, we define the player there. So whatever transformation we make to player should affect this automatically, which is why we're able to make this transformation on the rotation factor for the player, which is the rotation speed here. Okay, I get that. So this will not work here unless we define something that allows us to be able to control the rectangle transformation or the rectangle rotation itself. By defining something like this, you can find the rotation speed for it by, okay, we can do that. Let's derive. Let's derive a position. Let's derive a rectangle rotation. I don't want to call it rotation speed because there's no need. It's just going to rotate at a particular. Okay, let's call it rotation speed. Even if you're not like going to use it for now, you can always make changes. So that means I need to define that on the rectangle. Rotation speed is 0.1. So let me make it 0.5. I want it to be as fast as it can be. No, rotation speed is 30 degrees per second, which is this. Wow, okay, let's do this. Yeah. So what I'm doing basically now is to copy this, right? You can see making this copy, and let's see if it's going to work. Well, there's no assurance, but then we can. So one more thing I'm going to do is I'm going to also get a reference to what? Rectangle. So that way I will also be able to mute rect here and do this. Perfect. So let's see if it works. Yeah, we can't be that wrong, even if it doesn't work. I'm sure we can get something to work actually. So let's see. I'm scared I'm using the multiplication here. Should it be multiplication? Why did I not rebuild? Oh my god, I broke a lot of things. It's not even rotating again. It's not moving again. And the triangle doesn't rotate. Oh shit. Oh no. Why is this not working? Okay, so let's see. Let's do a trace back. We have the okay, I think there's a problem. Why do you multiply by -1? What kind of code is that? That's a terrible piece of code. Okay, so this already automatically breaks my code. Okay, I don't like this. Oh. Okay, I think that's all I need. I need the mutable reference. It doesn't need to be mutable here, but I need a mutable reference. So to avoid, oh no. So why does this successfully stop working with this? I mean the translation for the transform. I didn't tamper with it, so it shouldn't stop. But for some reason, it stopped. Even though I'm not making any significant change, that should cause it to stop. Interestingly, this should not be mutable because I don't need it. I'm only accessing the state. What am I doing? So currently transition is not even working. So it's not just because of what I did. Translation is not even working. Okay, so that makes sense. That's good to know. Good to know that we successfully broke the code just by adding this to it. But that should not be a problem. Why is that a problem? Wow. Okay, now we need to debug this to find out what it is because that should work. We've done the definitions properly with the rotation speed. We've done increments to the updating of that, not the shape now. In our own case, it's the rectangle. So we are successfully updating the rectangle just the same way this is being defined to rotate. By assigning it a speed, for you to rotate at. That's per second. Okay, so what else am I not doing here that should not make it work? Okay. I'm thinking of something because there's a bit of difference. This is a single equal. Okay, let's assume I'm correct on this. It's quite weird that, okay, how about we do this instead of I think I know why this failed here. Okay, you know what? This should still work. But I'm not going to give up on it yet. All we need to do is just try another way. So I'm going to destructure this just the same way they destructured this here. So I know there's no shape. I know. It's just one. In this case, I'll just call it shape. Then the shape is going to be, let me call it rectangle. So this will be this. But transform doesn't exist here yet. So I have to also destructure this by calling it oh, that is here. If I change this, what if I did nope, it has to be tied to this. Maybe. But I'm not going to give you the pleasure of being tied to it. I'm going to move it here. Mute reference. No, what are you doing? Okay, let's now work with this. Let's say sprite. I'm not going to even touch sprite position again. I'm just going to work with this. So this doesn't need the parentheses. But I'm going to leave it for now. That's not the paramount thing. Let's remove this for now. So this becomes rectangle and
it's 18 hours.
Transform. Yeah, let's call it transform. This is going to give a problem. Big problem. I can just feel it. Okay, so it's going to be a mutable reference. What am I doing? Why do I keep doing that? You cannot borrow rect as mutable. Okay, will this work? Let's try it again. All we did was just to tweak our existing code. Even if it fails, we successfully learned something. So let's see. Fingers crossed. Wow, it worked. So successfully got it to rotate, but now the translation fails. So which makes me wonder if I need to add translation twice. That might be a mature kind of implementation, but does it work? Yes. Is it bad? Absolutely not. All right, so let's try this. That makes sense. So what do we need to do? We see the rotation works perfectly well. The rotation works a whole lot. First of all, let me increase the rotation speed by 360. This is a bit small. Let me see. Let's make it 360. Let's refresh. And once we get this to work, we need to work on this because I need it to also work. I need to duplicate or implement double rotation until we see it work. We need to implement it. So that means the rotation needs to work. Currently not working. I mean the translation not working, but we can also get it to work. So two things I'm going to do. I'm going to actually leave the mutation here as based on what I have before. I'm going to leave this here. I'm going to define another one here. Mute rectangle, mute transform. I'm going to call it another name because now there's a duplicate transform. I'm going to add new transform to this also. Okay. Let's see if this works. If I get the error. Okay. So we got a big fat error, just like I said. Try to run event handler, but no handler was set. I'm sure it's because I'm using double transform in both places. Yeah, definitely. It says sprite movement access component transformed in a way that conflicts with the previous system parameter. Consider using width to create disjoint queries or merging conflict queries into a param set. Now we've learned how to do that, but then I'm still going to try this, and then I'm going to do something else entirely. I'm going to call it sub transform instead of transform. Let's see if it works. I don't expect it to work, but then I might be wrong. Yeah, exactly. So it's not going to work right now because we have two transforms here, and it's expected that one should fail entirely. Except if I can get the transform from the sprite position without using it here directly. Which should be a problem. Okay, let's see. Can we get transform? Okay, I'm just playing a dangerous game here. Playing a dangerous game that definitely should not work. Okay, yeah, we are back with the translation working, which is good news. Translation is working, rotation is not working. How is rotation not working now? So we finally got our transition to work even without the rotation, and that works perfectly well. So what we can do is can I group the rect and transform together in a single and try accessing them, but then I still need to destructure it into this format. Because it's a query, it's done as a list. This returns just one single instance, so it's easily accessible. Okay, let's do for another way to make it work. Yeah, it can't be that bad. All right, so let's try something else. Rotate this. We can't add rect to it because it doesn't work. So finally we understand, right? We saw that rotation worked, but because we have two things that are being rotated, that are rotating at the same time, they're just like we have this rotating too. Now let's look at how we can do that here. There are two rotation implementation. The first one is we are rotating the transform by rotating the factor by that of the ship rotation and multiplying that by the time, which works simply because we have the query here for the player, for the transform. Interestingly, I don't need to mutate this. I don't need to make it mutable. I just need to make it to have a reference of that. Remove this. Yep. And can remove this parenthesis because I don't need this, but that doesn't have any effect. So everything should still work as it is now. So yeah, worked as expected without this one rotating, right? Yes. So let's look at this. Update the ship rotation around the z-axis. You've done that. Bound the ship within the visible. Yeah, we've done that. Yeah, this is what I was saying. We can create this way. Now, looking at this, we created a transform to a query. We snap to players without player. Okay, which might be what we need to implement to make this work. So I'll probably remove this single again, add it to a query. Just maybe we have the direction, which direction in this case is more like the snap to this without this. So mute transform. And we need to set, okay, that might not be what we do. Without, you need to set without for it to work. With this, without this. So we're having a query of transform on now looking at this is what we are trying to implement, right? There's a query and there's a single. So it should work. Alright, so let's try it again. I'm going to leave it there. I'm going to add this transform to it again. And what I'm trying to do here is just a reference. There's no mutation going on. So just a reference of it with player. So we are going to do that. What did I do? Okay, so where was player transform used here? Player transform is used to get the player translation in 2D. So this means we can also get the direction of the rectangle here in 2D, and the same way query does that transformation, or the, what do you call it, Oh my god. The structuring. Yeah. Inside the loop. We can also destructure this inside the loop. We don't even need to define this here because it's not needed. And we can use that to define our rotation. So we can use the quad for rotation actually, rather than using the transform directly. Let's see if this works. I'm confident this should work. Okay, not extremely. We're quite confident this should work. So no player this time around. The player basically means the player translation. That's the position of the player minus the position of the enemy ship. Then normalize it. Get the vector from the enemy's ship to the player ship in 2D. Then normalize it. So basically what I need to do is get the player translation. That's rect transform dot translation dot x y. If I'm not mistaken, dot normalize dot extend. I'm basically just creating anything I see that will make my work here. This is how development works most of the time. You don't know everything. You make mistakes. You figure it out. You pick from everywhere. You join it together to make it work. So it failed again with another error. What's the error this time around? It says query this in system sprite movement access component transform event that completes the previous system parameter. Consider using without to create this join queries. Okay, so I need to use direction or something, or without ring. That's what I need to do. Just like we have the without player. So without rect, just like something like this, right? Is what we need to do. I feel it's not a valid query. Okay, you know what? How about I make this change with direction? No, with direction, but without rect. That's so weird. All right, so this case transform but found 2, so we can't use that anymore. Oh, that is so weird. So we can only work with transform. We can't even work with logo. Oh Jesus. Okay, definitely not going to do this. I'm going to leave it as it was before. I'll make this without this. What is happening? Taking it back to where it was before. We made this change. It's a mute direction, mute transform without rect. Yeah, so you still work as before. So if I'm not mistaken, we should get it working now. Nice, it works. But even though it doesn't rotate, but we successfully fixed the error by adding the right things inside of it. So yeah, I know why it's not working because we are not done. So we call this rectangle rotation. No, rotate rectangle. So we are going to say, how do we access the rectangle from here? Enemy transform, which nah, not that. So we want to call it rex transform dot rotation equal to rotate rectangle. Perfect. It doesn't work. What am I doing? And this fails. Why does it fail? Cannot immutable binding. Okay. Oh, that's true. It's not mutable. Perfect. Cannot borrow as mutable. No. Wait, what's happening here? What did it do? Oh, I forgot to add. Oh, jeez. Makes sense. Let's see. Fingers crossed. Everything should work fine now with actual rotation. No errors. So you only rotated once and stopped. So that means it works. It works now. So we successfully done both rotation. We've gotten both rotations to work. We successfully rotated the rectangle and the circle. But we want the circle to keep rotating, not just once, just like we have here. So going back to this, you can see how we are picking the result from here and making it work. So that means we are not done because we needed to continue the rotation. So in this case, I feel like I needed to keep rotating irrespective. What if I do this? Rex transform to rotate Z by a particular trying to be a bit creative. This might feel, I might work. Yeah, it works. It works. Perfectly works. All right, so we didn't need this. We didn't need the quartz rotation anymore. And we can remove the mutation from here because we can just read and that works. And yeah, so we finally got this to work by doing what we did initially, but we're just passing the wrong parameters to it, and that's why it was not working. But now we've gotten it to work successfully. If I'm not mistaken, now we have the rotation working and this working as well. But then I need this to rotate a bit more because it was to 400, right? So if it's greater than 400 and this one is less than 400, then it goes back to, it springs back, not like a springs back to the origin. So let's see what our results should be. Exactly. Now, the interesting thing is that you can see the light source actually reflecting where it goes. That's the bloom. That's the effect of the bloom. As it goes out, it feels like it's taking the light source with it and it's actually reflecting. So you can use this bloom in a way to like create on a dark surface and use it like, or even a word, create it like a word and use it in there. And as you can see, it looks like the sun shining. So yes, we've successfully done the rotation that we intend to for both, and that makes sense. So what's the next thing to do? Now we can see that we can also use the quart, right? Because even though we are not using the quart anymore, by which I removed, and I really don't want to remove that. It's a code I want to keep for future purposes because it will come in handy rather than having to go look for it. All right, so I'm going to take this and change it to 400 each of them, so it remains what it was before. Yeah, and now we do understand how this works, right? How this works. So the difference is that in this case we want it to keep working, keep rotating on its own, but in this case we want it to be based on the key press. So that's why we are doing that. So snap to player systems, we already understand that, and rotate to player systems. So it's basically just rotating with respect to the position of the ship. But in our own case, we are not implementing that yet. We are simply just implementing a way of implementing the translation and the rotation once. So I believe with what we've done so far, this with the examples we've checked, we can now understand how this works. So if we want to understand the movement, the rotation of the players, just like the snap to player system works, the snap to player system is what happens here, right? We get the position of the player itself, which is what we did here, X and Y, and then we snap it to the player by doing this. The two player, we get the vector of the player by getting the X and Y position and normalizing it, and then we use the quart to rotate the ship with respect to the player system. Now, this snap to player system is what happens when you refresh the page. You see that it snaps to the player. That means it rotates to the position of the player, irrespective of what position it was before. And that is what happens here. So it rotates to player by rotating on the y-axis to the position of the player. So now the actual rotation that happens with respect to the player is we create a time, which we always use, then we create a query. Now the query contains the rotate to player and the transform without the player. Now you understand how to use the with and without. You use the without because we assume that whatever component exists, whenever we run a query is observed, or let me say a query can operate on all of them. So you use the with or without to remove the structure you don't want the query to operate upon or to act upon. So in this case, we don't want it to act upon the players. So we have to define the players separately in a player transform. So what do we do in this case? We get the query, we get the with player and without player here. Rotate to player transform for the query. Player transform is single transform with player. So we get the player translation in 2D. The first thing we do, we get the player translation in 2D. And then we do the same thing, similar to how we snapped it. But in this case, we know that we are not snapping it because it's something that should be continuous. So whenever we can see it moves, we need to make that rotation happen. So we need to keep checking it. And then we have this cosine function, right? Like I said, it's just math. It's just mathematics, like I said already. And then you can see the rotate Z also to continue rotating. So it doesn't work like the quart that just does it once. So the rotate Z will continue rotating at every keyframe, which is why we were able to do that for this guy, the rectangle here, to keep rotating. So I hope this makes a lot more sense. So now looking at this is just Rust. You see the errors we faced, you see how we fixed it. Like I said, we're using this to learn Rust, right? Not just building a game, not just trying to build a game, because of course this is, if you ask me, this is a game. Yes, you're already working with building a game, but you're already handling the basics of gaming currently at this point in time. This is what we are doing. We're already implementing a basic game implementation that is not crazy enough that you cannot implement it, and that makes it easy for you to play by using your key to control it. So of course, it's not something that you jump or you fly or you do all of. But now you can do that with all of this. If you want to jump, you already know what to do. You know that you just need to apply translation to it. Translation does y instead of x to jump. If you want to rotate, if you want to slide or roll on the floor, all you need to do is you apply the rotate by x-axis, not z-axis. You apply rotate if it's a 2D game, you apply rotation by x-axis. If it's a 3D game, you apply rotation by z-axis, just like this, so that it rotates like this. This is a form of rolling on the floor. So you can see that you are building the building blocks for building an actual game. But you need to understand the concept first before talking about the building blocks. And then when you talk about light sources, know that when you get to some light sources, you see reflections, right? You see the light sources on your face. You need to actually build and plant those light sources. This is how you do it. You can create a light source like this bloom, make it a bit blur, so it's not as sharp as this, right? Make it a bit softer. We already have all of that implemented here. We can implement softness, which is what we use with U and J. If you implement softness now, you can see the light is softer than before. You can see that it automatically just dims. So it's not reflecting everywhere as before. You can see the softness now. We can continue increasing the softness for the threshold. So if you observe this with respect to the way it was before, change because so you get that now. So we are building the building blocks for games or for games by writing Rust already. So we are doing that. We are building the building blocks for games by writing our code basically. So this is exactly what we're trying to build. It's not something we get at once, but at least we spent 2 hours and 30 minutes trying to build this. It makes a lot more sense. And you can see we've already implemented rotation successfully. We've implemented this. So some of the things we've learned today is basically about, let's go back to what have we learned today. So today we've learned about, if I'm not mistaken, we've learned about meshes. We've learned about meshes. We've learned about translations. What we learned on day 2. We learned about meshes. We learned about translation on day 2. Number 1, we learned about meshes. Applying translations, transformations. Let me call it transformations. Transformations include translations, rotations, and yeah, basically translations and rotations. Then we also learned, I think that's the first one, in fact. We learned about lighting, working with bloom. And this is other one we did. Let me look at it again. We did tone mapping. Yes, I forgot that. Now let's see if I can move this. I want to move this. So what we learned about this. So we learned about blue lighting. We learned about meshes. We learned about transformations, applying transformations. Can I make this? So we learned about lighting, meshes, applying transformations. What else? I've learned about all that things. I can't remember what it is right now. But I think, okay, so what we did, we learned about, yes, using with and without. We learned about we already talked about spawn yesterday, but today was more practical. We did a lot more practical stuff today. We talked a lot more on transformations, meshes, creating shapes, basically. Talk about lighting, bloom, tone mapping, meshes, creating different shapes. So creating shapes like circles, rectangles, polygon, etc. So, and then we also did some other things. This is not the only thing we did. Let me see, from the code, we were able to apply transformations, we were able to apply tone mapping, we understand key presses, text, and all of those things. So yeah, basically this is what we were able to do. So we didn't implement this other one that has to do with movement of the ship or the rotation of the ship. We didn't do all of this, but what we did was we implemented all the transformation and added it to an existing implementation. So that means we could be able to combine three things basically. So we combine three examples into one to give us this example. So we're able to combine into one. First thing we combined was we created this, which is the original one, just a circle and a polygon, an hexagon to be precise. And then we changed it from there to adding translation, which we learned by translating a sprite. So we converted it from a sprite to actually translating a mesh. And then we now apply the rotation transformation on two different meshes that work concurrently within the app itself. And then we also worked with scale. We were able to scale the app itself. We work with scaling. So we work with different type of transformations today, the lighting generally, so that we can create light that works. So these are the things we've learned today. So this is good enough for today, because we don't want to like put too much on our head at once. We are learning this daily, and I believe that this is a very good place to stop today. We've learned a lot. We've been able to apply a lot of things. We've been able to start. I've been able to like bring it up to this point. Next thing I'll most probably like us to do before we go into 3D rendering, which we are going to look into same time tomorrow. But before we do that, I want us to look at this. We've already talked about flipping. I think flipping is just the rotation that we've done, which is like we've done more rotations here. So I think this should be the same. Then what we want us to look at, what I would like us to look at should be the animation, the sprite animation. This one, before talking about the 3D aspect. But basically this, because if you look at this now, we have sprite animation, animate a sprite in response to an event, then it renders an animated sprite. So there are two different things. You can animate a sprite maybe by key press. That means you can create a program of this sprite and then make it run by pressing the forward button, make it jump by doing maybe pressing the space button and stuff like that. So we can look at that tomorrow, right? So if you want to get notified on that, please hit the subscribe button, so that because I'm going to create the live schedule hours before we start, so you can get like pre-information, and then you can also prepare for the actual video. So that's what we're going to do. So we can do this, the sprite animation, the sprite sheet, and what next? So once we are done with that, you can see the text 2D. We don't need all of this, but we can always pick it up when we want it. And then render a sprite. We've already rendered the sprite. We already know how it works. So what we are going to look at tomorrow, starting tomorrow, is going to be the sprite animation and the sprite sheet. There's a lot of examples for us to cover. By the time we cover like 10 to 15 of it, we should be good to go. We should be able to create a 3D world like this. And it's like even a basic game, the 3D world that you can move with your mouse, you can move with your trackpad, you can move with the keyboard, you can do all sort of things. And this also create 3D shapes with shadows. We can do all of those things. It's not as crazy as it seems. They are just things we can create and share, and then explore and learn more about and create more with stuff like that. So that's basically what we're trying to render here. So transparency in 2D, we can see 3D rendering in this case. We can see 3D scenes with shadow, literally. So instead of creating a 2D shape that has the lightning that's, that's, what's the word to use? That reflects, yes, that reflect on. So it's more like creating a light source. This is more like creating a light source, because the lights reflect on anything that is around it. And you can see that you don't need to do anything crazy for that to happen. Bevy already handles that for you. It's just being applied to whatever environment it is. You can see how this changes color, right, when it moves, and we're able to do that successfully. So that is what we are going to do today. So the next thing tomorrow, what we are going to be tackling tomorrow is the undo the animations first. So we are just going to jump into animation straight away tomorrow and talk about sprite animation, sprite sheet, right? And Then we are going to talk about 3D rendering. So I'll try my best to get these sprites available so we can use that to test it out. And then we're going to go into 3D renderings, 3D shapes. So now 2D, 3D, depending on what you're trying to make, both make sense. There are a lot of 2D interfaces, but currently these days we do a lot of 3D. Even avatars have 3D. So we want to actually work with all of these 3D stuffs too. So we're going to look at the 3D aspects of things tomorrow, 3D scenes, 3D shapes, 3D world, animated materials, but we just keep it simple. First of all, when we deal with the sprite animations, then we can move into 3D. So yes, that'll be all for today. Thank you guys for connecting, and I hope you guys have learned something. This. So if you have any question, drop it below in the comment section, and I really appreciate if you guys subscribe so that, you know, like I said, it shows that people are actually learning from this, and drop a like also. It's very much appreciated. And then I would like more of you guys. And then if you feel like they need this also, please feel free to share it to them, because like I said, we are all learning together, right? You can see the mistakes I made today. That's how we learn. That's how development is. There's no magician in writing software or writing codes or writing anything. So even if you have an idea before, you still make mistakes, and see how we're able to fix it. We pick from here, we pick from here. We made informed decisions, and we're able to use it. Why? Because we understand how the language works. So that's what we are learning together. But you learn by building, and then you can make informed decisions also. So if you know anyone that is interested also in something like this, feel free to, you know, share it with them also, so that they can do something similar. Yeah, so that'll be all for today. Thank you so much for joining, and hope you learned something once again. Catch you guys tomorrow.